know it's like, oh.
Hello guys, welcome back to our YouTube channel Algorithm Pod. My name is Jitesh. So here I am with the next video of cryptography and network security. Now, we were discussing the substitution techniques of cryptography. Now, another substitution technique is Playfair Cipher. Now, until now, we have seen of replacing one character at a time. So in this Playfair cipher, we are replacing two characters at a time, which means we are selecting a pair and then we are converting plain text to a cipher text. Now how we can do it, let's try to understand with example. Now here is our plain text called instruments, and this is a keyword. As I said earlier, we use keys to encrypt and decrypt the message. Now what we need to do is we have taken this keyword. Now we represent this keyword in the form of a matrix, of a 5 by 5 matrix. So alphabets are 26, so we need to omit one character. So in this case, as you can observe in this matrix, I have not written J anywhere, so we need to omit J. Whenever there is J in the plain text, it should be replaced by I. Just try to remember this. Now as I said, this keyword is represented in a matrix like this: monarchy, MONARCHY. First the word is written like this in the row wise fashion. Then next, the remaining cells are filled with remaining alphabets. Try to always remember, we do not write J, or you can write like this also, INJ in combination. Now as we said that Playfair cipher encrypts two pair of letters at a time, two pair of characters at a time. Now look at this, we have total, now observe this, we have total 11 characters here. Now we act as a pair, so there is one character short, so we add a random character, a dummy character basically, to this SZ. We have added a random character Z to here, so that we can act on pairwise. As I said earlier, the Playfair cipher acts on a pairwise fashion. Now how we can perform the encryption or decryption process, let's see this. Now there are couple of rules to remember. These are the rules. If the characters are lying in different rows and different columns, we need to choose the row of first character and row of second character. I will explain each and every rule in detail while we are doing the example. Now try to remember this. Same, if the characters are in same row, then replace the character with next immediate character, and the same column, replace the character with the character which is below the exact character. Now let's try to don't get confused. I will explain this detail. I will explain these rules in detail in the example. Now this is our plain text, so we are acting on pairs at a time. Now first we have taken I and N. Now look for the I and N. Now we have taken our first pair I and N. Now look at the matrix first. Now where is I? Look at the I here, the first character, and the second character N. Now they are clearly at different rows and different columns. What happens, as I said in rule 1, different rows and different columns. Row of first character, we have to take the row of first character. In this case the first character is I, this is the row, and the column of second character, this is the column. What is the common element between these two rows and columns? G. So we need to replace I with G. Now same goes for N. In this case, N is the first character and I is the second character. Like this we need to act. Now N is here and I is here. What is the common between these two? This row and this column. What is the common element? A. So we need to replace N with A. So we have applied rule 1 over here. Now let's take the second pair ST. This is the second pair ST. The first character is S. Look into the matrix. S and T, they are in the same row. So what happens when the characters are in the same row? Next immediate character. So S is replaced by T like this, and the T, there is no immediate characters here. So come from start. It is replaced with L. So T is replaced with L. Rule number 2. Now R and U, it is rule number 1. Now I will show you directly what happens when the characters are in the same column. Now let's take this pair ME. ME. Locate M and E in the matrix. This is M and this is E. Now what happens according to the rule 3, when the things are in the same column? Replace character with the character which is exactly below in the same column. Now in this case I will have taken M. What is the character which is below the M? Is C. So we need to replace M with C. Now we have E. What is the character which is below E? L. So we need to replace E with L like this. Now same thing goes for all the other pairs, and we can obtain the ciphertext like this. Now we have same goes for decryption. Decryption is exactly the reverse. The same rules are applied, but remember this thing: in decryption, when the columns and when the characters are lying in same row or same column, we need to take if the characters are lying in the same row, then we need to take the previous characters. In encryption, we have taken the next character like this. We have taken T and L, right? T and L are in the same. The previous character, there is no previous character, so we will come from end. So we have replaced L, T. We have replaced L with T like this. L with T. Like this we need to perform. So that's it guys for this video. Thank you for watching this video. Make sure to like this video, subscribe to our YouTube channel Algorithm Pod, hit the bell icon for a future notification. See you guys in the next video.